Assalamualaikum dan selamat malam semua. Selamat datang ke program PKP Unit Kimia iaitu Rising Star in Chemistry minggu 7 mengenai Chapter 1 Method. Hari ini kita akan bersiaran mengenai teknik menjawab soalan PSPM bagi nombor 3, 6, 7 dan 8. Jadi tanpa berlengah masa lagi, saya perkenalkan penceramah kita iaitu untuk siri ini adalah Puan Anida binti Abdul Rashid, iaitu pensyarah kanan Unit Kimia Grade C54. Silakan Puan Anida.
Okay. Hai, apa khabar semua? Okay, saya Puan Anida binti Abdul Rashid, selaku pensyarah kanan di Unit Kimia. So malam ini kita akan bersama-sama membincangkan skema jawapan untuk beberapa soalan PSPM. Okay, jom kita mulakan.
Assalamualaikum dan selamat malam. Apa khabar semua? Harap semua sudah bersedia untuk program Rising Star minggu ini. Saya, Madam Anida dan Madam Nurul Azwa telah menyediakan bahan untuk topik 1 iaitu Matter. Saya telah memilih 4 soalan pasir yang bersesuaian untuk dibincangkan pada malam ini. Madam harap you all semua sudah cuba menjawab soalan-soalan ini sebelum ini. Okey, sekarang mari kita semak jawapan bersama-sama. We start with question number 3A. Vinyl chloride is prepared by the reactions of ethane gas with hydrochloric acid. In the preparations of vinyl chloride, 70 grams of ethane gas is reacted with 102 grams of HCl. Write a balanced chemical equation for the reaction. So, from the question, we know ethane gas react with hydrochloric acid to produce vinyl chloride. So, this is the answer. 1 marks for complete balance equation. We go to question number 2. Identify the limiting reagent in the reaction. Okay, so to determine limiting reagent, firstly, you must calculate number of mole for each reactant. Okay, now we have mole of ethane gas, 70 grams divided by 26 grams per mole. So you get mole of ethane gas 2.6923 mole and mole HCl 2.7945 mole. Okay, so now we will compare given mole with equation. So from equation, we have 1 mole ethane gas need to react with 1 mole of HCl. Okay, so if you have 2.6923 mole of ethane gas, mean we also need 2.6923 mole of HCl. Okay, so from here we know mole HCl needed is more than mole HCl given. So this is mole HCl given. So here we can say ethane gas is a limiting reactant. Okay, now, okay, so for identify and determine limiting reactant, you can get 5 marks. Number 3, calculate the mass of the product. Okay, so to calculate mass of product form, we must use or we must refer to the limiting reactant. So from question number 2, we know ethane gas is a limiting reactant. So we will compare number of mole limiting reactant with mole product form. From equation, we know 1 mole ethane gas will produce 1 mole product, vinyl chloride. So if you have 2.6923 mole of ethane gas, mean we will have 2.6923 mole of vinyl chloride. So from mole of vinyl chloride, we will multiply by molar mass and we will get mass of vinyl chloride produced, 168.27 gram. So for this question, okay, 1 mark for the statement, okay, 1 mark for the mole of vinyl chloride and 1 marks for mass of vinyl chloride. Okay, now we go to the question number 4. Calculate the mass of excess reactant. Okay, as we know, HCl is a excess reactant. So this is mole of given 2.7945 mole minus with reacted HCl 2.6923 mole. So you get mole of excess HCl 0.1022 mole. So to get mass, we must multiply with molar mass 35.5 gram per mole. So the answer is 3.73 grams. So also for this question, you can get 3 marks. Question 3b. Magnesium is an element with a proton number of 12. In a sample of magnesium, it was found that magnesium have 3 different nuclear numbers, which is 24, 25 and 26. Write the symbol for one of these 3 atoms, showing its proton number and nucleon number. Okay, so to write symbol, okay, we must use proton number and nucleon number. So this is the symbol for isotope magnesium 24, magnesium 25 and magnesium 26. So take note, okay, bila kita tulis symbol for atom, okay, symbol for atom, make sure proton number kat bawah and nucleon number kat bahagian atas. Okay, so for magnesium, we have 3 types of isotope, as 24, 25 and 26. For this question, you can get 3 marks. We go to question number 2. A sample of magnesium contain 78.6% of atom with nuclear number of 24, 10.1% of atom with nuclear number of 25 and 11.3% of atom with a nuclear number of 26. Calculate the relative atomic mass of magnesium. So, kita akan guna equation average atomic mass equal to submissions of abundance time with isotopic mass divide by submissions of abundance. Okay, so di sini kita assume 78.6%, 10.1% and 11.3% ini adalah percentage abundance, and 24, 25 and 26 refer to the mass of isotopic. So, you darab lah 24 times 78.6 plus 25 times 10.1% plus 26 times 11.3%. So, divide by total number of percentage abundance. So, kita tambah yang ni. 78.6 tambah 10.1 dan 11.3. So, you dapat total dia 100%. Okay, so kita calculate and then you can get 24.3 U. So, this is average atomic mass. Okay, you get average atomic mass. So, now the question asks you to calculate relative atomic mass of magnesium. Mean you must compare average atomic mass with 1/12 times mass of carbon 12. So, kita untuk hilangkan dia punya unit. Okay, kita akan bahagi dengan 1/12 darab 12 U. So, the answer is 24.3. So, for this question, you can get 3 marks. Okay. Now, we go to second question. sketch and label the expected mass spectrum of the magnesium. So kita tahu mass spectrum, normally untuk mass spectrum kita akan lukis abundance dan juga mass over electron. So kita tulislah ini percentage abundance. Ini kita punya refer kepada nuclear number. So awak buat macam ni lah. So untuk soalan ni pun awak akan dapat 3 markah. 1 marks for labeling pasti X and Y. Percentage abundance and ME. And then awak label dia punya nilai percentage abundance. Now we go to the question number 2. I choose question 6 from the past year question. Sodium carbonate dissolved in ethanol to give 2.5 molar solution. Calculate the molality of the solution if the density of the solution is 1.43 gram per mil. So first we assume volume of solution equal to 1 liter or 1000 ml. And then by using density, we can calculate mass of solution. So density, mass of solution equal to density times volume. We assume volume 1 liter or 1000 ml. From using density, we can determine mass of solution. 1430 gram. And then after that, by using molarity of sodium carbonate, we can determine mole of solute. Mole of solute equal to molarity times volume. So molarity 2.5 times volume 1 liter because we assume volume 1 liter. So you can get mole of solute 2.5 mole. So kat sini kita boleh awak boleh dapat 1 marks for assumption. 1 marks for substituted density and volume, and then 1 marks for mass of solution. And then 2 marks for calculation mole of solute. So total marks for this question you can get 5 marks. After that, by using mole solute, we can calculate mass of solute. Mole of solute times molar mass of sodium carbonate 106 gram per mole. So you get mass of solute 265 gram. After that, we can calculate mass of solvent. Mass, as we know, mass of solution, mass of solution equal to mass of solvent plus mass of solute. So we already know mass of solution and mass of solute. Ni kita dah kira sebelum ni, mass of solution and mass of solute. So from that, we can calculate mass of solvent. So mass of solvent equal to 1165 gram. Mass solution minus mass of solute. So kita dapat mass of solvent. After that, we convert from gram to kilogram. 1165 divided by 1000. So you can get 1.165 kilogram. So for molality equal to mole of solute divided by mass of solvent in kilogram. So after that, you can get the answer 2.15 molal. Molal, or you can write 2.15 mole per kilogram. Now we go to question 6b. The following redox reaction occur in acidic condition. Balance the redox equation using ion electron method. Okay, so first step, we divide the equation into half equation. So kita nak divide ni senang je. Awak divide ikut jenis atom. Ya, zinc akan jadi zinc 2+. Okay, and then NO3- akan jadi ammonium ion. Yeah, so kita divide into half equation. After that, kita check atom. Okay, so untuk first, NO3 become NH4+. So kita check lah. Nitrogen balance ada 1. Okay, and then kat sebelah kiri ada 3 oksigen. So that's why you must add with 3 mol of water. Okay, sebab kita ada 3 oksigen kat sini, sini kita perlukan 3 mol water. Okay, after that we calculate number of hydrogen. Ya, so tengok sebelah kanan ni kita ada 4 tambah 6, 10. So kita kena tambah lagi dengan 10H+ sebelah kiri. Okay, ya, so atom dah balance. Kemudian kita check dia punya charge. Okay, ni -1, sini positif 10. So -1 tambah positif 10, so jadi berapa? So kita akan dapat positif 9. Sini positif 9, di sini positif 1. Positif 9, positif 1. So kita kena tambah dengan 8 elektron. 8 elektron ni maksudnya tolak 8. 9 tolak 8 dapat positif 1. So sebelah kanan ni pun dah ada plus, so positif 1. Okay, dah balance. Okay, so ini cara kita nak balance using ion electron method. Okay, and then for second equation, zinc become zinc 2+. So atom dia dah balance, so kita check kita punya ion je lah. Sebelah zinc ni kosong, sebelah zinc 2+, 2+ sebab dia ada positif 2. That's why kita tambah dengan 2 elektron. Okay, after that, kita kena samakan bilangan elektron. That's why second equation must multiply by 4. So bila dah ada 4, dia dah sama, so kita boleh cancel out. Okay, final answer, you can get 1 mol NO3- plus 4 mol zinc plus 4 mol H+, produce 1 mol ammonium ion plus 4 mol zinc 2+ plus 3 mol water. Okay, so this is redox equation. 6b2, a 4 grams impure sample of zinc reacted completely with 25 ml of 0.5 molar nitric acid. Solution. Calculate the percentage purity of the zinc sample. Okay, so for this question, it's when you calculate the percentage purity of the zinc sample. First step, we calculate number of mole of nitric acid. Okay, using volume and concentration given. So you get mole of nitric acid equal to 0.0125 mole. Okay, and then we will compare with equation. So from equation or balance equation, we get 1 mole NO3- react with 4 mole of zinc. So if we have 0.0125 mole NO3- mean we have 0.05 mole zinc. So after that, we determine mass of zinc reacted. 0.05 mole times molar mass of zinc. So you get 3.27 grams zinc. So to determine purity of zinc, we get 3.27 divided by 4 times 100. So the answer will be 81.8%. Okay, now we will discuss question number 3. So I choose question 7 in PSPM question. So this is question 7. A, B and C. We go to question 7a. A 25 ml of 0.05 molar silver nitrate solution is mixed with 25 ml of 0.05 molar of calcium bromide solution to give 0.105 grams of solid silver bromide. Write the balanced chemical equation. So from the statement or from the question, we have silver nitrate mix means react with calcium bromide. So formula molecule for silver nitrate AgNO3 plus calcium bromide CaBr2. Okay, produce silver bromide, so AgBr plus CaNO3. So this is the balanced equation. 2 mole of silver nitrate react with 1 mole calcium bromide, produce 2 mole silver bromide plus 1 mole calcium nitrate. Question number 2. Determine the limiting reactant. Okay, so first step, we calculate number of mole for each reactant, which is silver nitrate and calcium bromide. So we have 1.25 times 10 power of minus 3 mole silver nitrate and also 1.25 times 10 power of minus 3 mole of calcium bromide. Okay, mole of silver nitrate and calcium bromide are equal because we have same volume and same concentration. Okay, after that, we will compare mole given with equation. 2 mole of silver nitrate equal to 1 mole of calcium bromide. So if we have 1.25 times 10 power of minus 3 mole silver nitrate, mean we need 6.25 times 10 power of minus 4 mole calcium bromide. So from here, we can see mole calcium bromide given is larger than mole of calcium bromide needed. Thus, limiting reactant is silver nitrate. Question 3. Calculate the percentage yield of silver bromide. Okay, from equation, we know 2 mole silver nitrate will produce 2 mole of silver bromide. Okay, so daripada sini kita tahu mole silver nitrate akan bersamaan dengan mole silver bromide. So before this, we have 1.25 times 10 power of minus 3 mole of silver nitrate. Therefore, mole of silver bromide is 1.25 times 10 power of minus 3 mole. So to calculate mass of silver bromide, we must multiply by molar mass of silver bromide. So you get the answer 0.235 gram. So to calculate percentage yield, we will use formula actual yield divided by theoretical yield times 100. After that, we get the answer is 44.7%. So total marks for this question is 3. Question 7b. An organic compound contains only carbon, hydrogen and oxygen with a mass composition of 41.4% carbon, 3.47% hydrogen and 55.13% oxygen. If 0.05 mole of this compound weight 5.8 gram, determine its empirical formula. Okay, so first we construct table like this. Okay, and then we have element carbon, hydrogen and oxygen. Okay, so from the question, we can get mass of carbon, hydrogen and oxygen. So 41.4% carbon mean 41.4 grams of carbon, 3.47% hydrogen refer to 3.47 grams of hydrogen and 55.13 grams oxygen. Okay, after that, we determine number of mole for each element. So for carbon, we get 3.45 mole, hydrogen 3.47 mole, and oxygen we have 3.45 mole. Okay, after that we will determine smallest ratio for each element. Okay, we multiply with the smallest number of mole. So 3.45 divided by 3.45. So for simplest ratio, for each element we get 1. So empirical formula is CHO. Okay, now 7B2, each one you determine its molecular formula. So we will use formula empirical formula times N equal to molecular formula. Okay, so firstly you calculate empirical formula, molar mass for empirical formula. So we have CHO. So this is molar mass untuk empirical formula. Okay, and then after that we can calculate molar mass molecular formula, okay, using mole and mass, okay, mass of compound. So before this we know mole equal to mass over molar mass. Okay, so now we already have mass and mole. Okay, from question we have compound weight and number of mole. So from question you can calculate molar mass molecular formula. Okay, so molar mass untuk molecular formula is 116 gram per mole. Okay, so we will substitute in this formula. So empirical formula is 29. Okay, empirical formula 29. So you can calculate value N. Okay, molecular formula 116. Okay, so you can get N equal to 4. N equal to 4, and molecular formula is C4H4O4. Okay, so for this question you can get 4 marks. Okay, now to question 7C. Okay, the reaction between acetic acid and barium hydroxide produce a salt. Determine the maximum mass of the salt obtained if 17.13 grams of barium hydroxide is used. So first step, you write the equation. Acetic acid react with barium hydroxide, so you get barium acetate. Okay, so this is question. Awak kena balance kan. Okay, lepas awak tulis equation and then awak cuba balance kan persamaan ni. Okay, and then we calculate mole of barium hydroxide. Okay, this is mass barium hydroxide. So from mass we can determine number of mole of barium hydroxide equal to 0.1 mole. Okay, so from equation we can see 1 mole barium hydroxide will produce 1 mole of barium acetate. Okay, so if you have 0.1 mole of barium hydroxide will produce 0.1 mole of barium acetate. Okay, so this is molar mass. So nak kira molar mass, tahulah kan, barium tambah 2 carbon tambah 3 hydrogen, Ini awak tambah semuanya lah. Okay, barium tambah 4 lah. Ni 2 darab 2 jadi 4. Tambah 6. Okay, 4 karbon. 4 karbon tambah 6 dan tambah 32 darab 2. So tambah total, this is molar mass untuk barium acetate, 255.3 gram per mole. Okay, so kalau kita nak cari mass, so mole times molar mass. So the answer will be 25.53 grams. So this is the mark for this question. Total marks equal to 5. Okay, so untuk question 8A1, write the notation for all isotope of bromine. So ingatkan, kalau nak tulis isotopic notation, kita ada simbol for element and then proton number and nucleon number. Okay lah, so daripada soalan kita tahu proton number of bromine is 35. So BR, okay, 35 proton number and this is nucleon number. Okay, bromine 79 and bromine 81. So untuk bromine dia ada 2 isotop. Okay, now kita tengok soalan 8A2. Calculate the relative atomic mass of bromine. So ini kita akan guna average atomic mass equal to submission percentage abundance over percentage abundance time isotopic mass divided by submissions of abundance, percentage abundance. Okay. So bila kita kira average atomic mass, so ini kita ambil dia punya isotopic mass, so ini percentage abundance. Refer kepada diagram tadi lah. Okay, so you dapat average atomic mass equal to 80 U. Okay, so take note, bila soalan nak relative atomic mass, so maksud dia tak ada unit. So kita kena compare average atomic mass with mass of carbon 12. Okay, untuk hilangkan unit. So you dapat relative atomic mass, okay, for bromine adalah 80. Okay, now we go to question B. A reagent bottle contains a stock solutions of 0.9% biomass of sodium chloride NaCl. The density of the solution is 1 gram per cm3. Calculate the mole fractions of sodium chloride. Okay, so first kita kena tahu dahululah mole fraction. Mole fraction maksud dia mole solute divided by mole total. Kalau kita ada solution, mean total awak tu terdiri daripada solute plus solvent. Okay. So di sini given to you 0.9% biomass. So kita assume 0.9 over 100. So maksudnya mass of solution adalah 100 gram and mass of solute 0.9 gram, and from here you can calculate mass of solvent. Yeah, daripada percent biomass, normally we can calculate mass of solvent. Tolaklah 100, tolak 0.9, so you dapat mass of solvent 99.1 gram. Okay, then kita boleh cari mole of sodium chloride. Kita dah ada mass of solute. Okay, daripada mass of solute, we can calculate mass number of mole of sodium chloride. Okay, so kita ada sekarang ni mole of sodium chloride ataupun mole of solute 0.0154 mole. Okay, kemudian kita nak cari mole of solvent. Okay, mole of, ambil daripada ni lah, mass of solvent divided by 18. Okay, so you dapat mole of solvent. Okay, so to mole fraction, okay, untuk mole fraction kita tahu mole solute divided by mole solution. Solution kita ada water and solute. Okay, so you ambil lah mole NaCl divided by mole NaCl plus mole water. So mole fraction for NaCl equal to 0.0028. Mole fraction tak ada unit. Okay, dan nilai dia mesti kurang daripada 1. Kata tiba you kira mole fraction, you dapat 1.2 or 1.3. So maksudnya tu salah dah tu. Mole fraction normally nilai dia less than 1. Number 2, the molality of sodium chloride. So by using equation, molality equal to mole of sodium chloride divided by mass of solvent in kilogram. So just substitute nilai je lah. Ini kita ambil daripada soalan nombor 1 tadi. So mole of solute or mole of sodium chloride 0.0154 mole divided by mass of solvent. Make sure you convert into kilogram. Yeah, so you dapat jawapan dia 0.155 molal. Question 8b3. Calculate the volume of the stock solution required to prepare 100 ml of 0.01 molar sodium chloride solution. Okay, so from question B1, we assume mass of solution 100 gram. And then by using density, we can calculate volume of solution. So when mass solution 100 gram, mean volume of solution 100 ml. So first step, you must calculate concentrations of stock solution. So using molarity equal to mole of solute divided by volume of solution. So you get concentrations of stock solution 0.154 molar. Okay, after that, to calculate volume of the stock solution required to prepare 100 ml of 0.01 molar sodium chloride, we will use M1 V1 equal to M2 V2. This is dilution process. Okay, from 0.154 molar, kita nak cairkan dia menjadi 0.01 molar. Okay, so substitute value and you can get V1 equal to 6.5 ml. Okay. Question 8c. Okay, silicon tetrachloride SiCl4 can be prepared by heating silicon in excess chlorine gas. So this is equation formations of silicon tetrachloride. Okay, so question number 1. Calculate the mass of silicon needed to produce 400 gram of silicon tetrachloride if the percentage yield is 42.5%. So maksudnya soalan ni kita nak cari mass of silicon yang diperlukan. Okay, so using percentage yield 42.5%, so we can calculate theoretical yield. Okay, so substitute value in equation or formula. Yeah, in formula, percentage yield equal to actual yield divided by theoretical yield times 100. So from here, we can calculate theoretical yield. So theoretical yield equal to 941.176 gram. Okay, so daripada theoretical yield ni, kita kena cari mole. Okay, so using theoretical yield, so kita akan dapatkan number of mole of silicon tetrachloride produced. Okay, kita cari mole dia dahulu. Kemudian from equation, we know 1 mole silicon will produce 1 mole silicon tetrachloride. So if you have 5.533 mole of silicon tetrachloride, mean we need 5.533 mole of silicon. Sebab soalan nak cari mass of silicon, so kita kena tahu mole of silicon. So bila dah ada mole, kita boleh cari mass. Okay, ambil mole darab dengan molar mass silicon. So the answer will be 155.48 grams. Okay, now we look to question 8c2. If 15 mole of chlorine is used, determine the amount of unreacted chlorine. Okay, sebab kita tahu excess chlorine. So dia nak cari the amount of unreacted chlorine. So from equation, we know 1 mole of silicon need or react with 2 mole of chlorine. Yeah. So if we have 5.533 mole of silicon, mean we need 11.066 mole of chlorine. So now you have 15 mole. So tolak je lah. So nak cari unreacted chlorine gas. So 15 mole minus 11.066 mole. So you dapatlah the answer will be 3.93 mole. Okay. So habislah 4 soalan PSPM. So Madam harap sebelum Madam akhiri program kita malam ni, Madam nak berfikir sikit lah tengok gambar ni. Okay, Madam harap you all semua taklah menjadi macam gambar penggali ni. Okay. You never know how close you are and never give up on your dreams. Okay, awak mesti terus mencuba sampai awak mencapai kejayaan. Okay. Okay, that's all for today. Thank you.